All right, today is lesson 1.5. We're going to solve some linear equations and inequalities, something you should be familiar with, but we'll just kind of go over how to do that. Again, if you hear anything in the background, it's my son watching something crazy on YouTube. So let's begin. Solve 10 plus 3 times 2x minus 4. You should always remember to distribute first. 6x minus 12. Keep the 10 equals. When there's a minus sign in front of parentheses, I just like to distribute it. So 17 minus x minus 5. And then we're going to get all of our x's on one side and numbers to the other side. Actually, we can still simplify this side, so I might end this side. Let's do that. 6x, 10 and negative 12 make minus 2. And this would be 17 minus 5 is 12 minus x. I like to get all my x's to be positive, so I'm going to bring this one over to this side. So that would be 7x. And then I'll bring plus 2 over to that side, be 14. So x equals 2. So my solution set would be written like this, 2. Okay? Sorry about all the shadows here. Let's do another one. Let's do a fraction one. When dealing with fractions, if I see fractions in an equation, I definitely try to get rid of them by multiplying through by a common denominator. So if you think this is over 1, all of these have a common denominator of 12. So I'm going to multiply this entire side by 12 and this entire side by 12. And really what you're doing is you're multiplying each term in the parentheses by 12. So 6 goes into 12 2 times. So you're really going to multiply just this top by 2, 2x plus 14. And then 2 goes into 12 6 times. So you're going to multiply this one by 6. So you would have plus 12x minus 48. And then multiplying this by 12 is negative 48. So you can either, again, multiply each thing by 12. Sometimes I make my students write it like this so that way they can see, oh, the bottom cancels and I'm left with 2. If I multiply this by 12, it cancels and I'm left with 6. And I need to do 6 times that numerator. And now you have this nice fraction, this fractionless problem. It has no fractions in it. So let's clean this up. So 2x and 12x is 14x. Let's see, 48 and 14 is 34 equals negative 48. And then we're going to add 34 over to that side. And we're going to get negative 14. And then divide by 14. And we get x equal to negative 1. So our solution set, again, is negative 1. Let's do one with decimals. Whenever you are working with decimals, it's just like fractions. You want to multiply through by the common denominator, which would be what is the decimal place, the highest decimal place. So this is 100th, this is in the hundredths, this is in the hundredths. So we're going to multiply everything through by 100. And again, you can think of it multiplying both sides by 100. Sometimes, like I did before, you can multiply this by 100, this by 100, and this by 100. And what that does is 100 times 0.06 just becomes 6x. It moves the decimal place over, so it becomes a whole number. 100 times 0.09 becomes 9 times this 15 minus x. You don't have to do the 100 times this parenthesis also, because multiplication just goes from left to right. You just multiply it right there. And same thing here, 100 times 0.07. You could do the 100 times 1500, but that's not going to help you get rid of that decimal anytime quickly. Just do 100 times 0.07, which would be 7, and then times the parenthesis 15. And then let's just clean this up. So 6x plus 135 minus 9x equals 105. So that would be negative 3x plus 135. Whoops, is 105. And then I would have negative 3x, subtract the negative 135 over, and you get negative 30. So x is 10. So there's my solution set. So just some examples there. Let's do this on the graphing calculator, which I think is always a nice, if you're allowed to use the graphing calculator. Again, you do want to practice without the calculator. But let me just show you how to do this real quick in the calculator. And I did something on purpose here. I left the plot one on because I have a feeling many of you might have a plot one on. But type in we're going to do two different types of methods. One is called the intersection of graphs. The other one is called the x-intercept method. We're going to do both. You can use these as a nice way to check. But type in f of x, 5.91, x plus 13.7, and then negative 4.71, x plus 64.7. Now, if your plot one is on, just go up to it, hit enter. What that does is it turns it off. And now we're just going to go to our basic viewing window, which is Zoom 6. And we're going to look to see where they intersect. Give my little thing a moment in time here. Okay, so as you can see, they're outside the window. So what I'm going to want to do is change my window. So let's see if I can change my window to something higher. How do we know to change our window? You can see the y-intercept is 64.7. This one is 13. We're going up by 5. We're going down by 4. So we definitely want to change our window to something where we can see these numbers right here in the intercept. So let's try changing our x min to be, we'll start with like negative 20 and 20. And we can go by 2s. Our y min definitely wants something higher. So we'll do like negative 100. 100 will go by 10s. Let's see if we can see a better view there. I'm sorry about the brightness of my calculator here. There we go. So now we have a better view, definitely, than before. So this intersection right here, I want to find that intersection. It's really easy, something you really should memorize. It goes like this: second calc 5, enter, enter, enter. Second calc 5, enter, enter, enter. I'm just going to write that down. Second calc 5, enter, enter, enter. And I'll just show you what second calc 5, enter, enter, enter does. So if you hit second, calc is right there above the word trace. 5 says intersect. So you hit 5. And now it's going to ask you 3 questions. First curve, your first curve in my case would be this blue line right here. So you hit enter. Then it moves it to the red line, enter, and then it's going to take a guess, enter. So my intersection is at right here. Might be hard for you to see, about 4.8, 42.08. 4.802, 42.081. Now again, which number are we more concerned about? We are more concerned about the x that they are sharing. So that would be the solution, okay? Now let's do another one using what's called the x-intercept method. So the x-intercept method says the following: you would want to find an x-intercept. So you would actually take this entire equation and move it over and set it equal to 0. So set equal to 0. By the way, I want to highlight that, so I'm going to make that circle a little bit. So 6x minus 4 times 3 minus 2x minus the 5 times x minus 4, but then you add the 10 and set it equal to 0, okay? And now you don't have to simplify this at all. Just type it in all into one equation. See, whereas here we put this into y1 and put this one into y2. This one we're just going to type all into the y1, okay? This all goes into y1. So be very careful how we type it. 6x minus 4 times 3 minus 2x parenthesis minus 5 times x minus 4 plus 10. And I'm just going to go back to Zoom 6 just to see if we can see it intersect the x-axis in here. Might have to change the viewing window. Now we got it. Okay, so when you set it equal to 0, you were looking for the x-intercept. Where is it intersecting the x-axis? Okay, so if you want to draw yourself a little picture too, that's always helpful. Right there, that is the point that we're looking for. Now, how can we find that point? Actually, calculator will do it for you also. If you hit second calc, this time don't hit 5, you can hit 0, because remember, the x-intercept is called the 0. So 2, and then it's going to ask you left bound, right bound, guess. So you want to be left bound, which would be left of the 0 down here. Right bound would be above the 0. So where am I at right now? There we go. So I want to be on the left, hit enter, and it doesn't matter where you go. And then above, hit enter, and then hit enter again. -2, 0. And we kind of knew that it was going to be on -2 because you can count. So -2, 0. Again, the -2 is the x that would solve this equation. So there's 2 ways to do it on the graphing calculator. All right. Just a real quick 2 definitions right here. A contradiction is an equation that gives no solution. You would actually have 2 parallel lines, because if you have a solution like we saw up in this one on our graphing calculator, they would intersect each other. When they intersected, that was the common x they had. But when they have no solution, they're contradiction, they're parallel. Here would be an example, 2x plus 7. That would be like this one right here, plus 7, 2x minus 5. Well, it would be down here somewhere. But this would not work if I go to subtract my 2x. I end up with 7 on this side and then -5 on this side, and then equals in the middle. Is that a true statement? Does 7 equal -5? False. So this is no solution. Sometimes we write it like that, but this is no solution, 2 parallel lines. You could get what's called an identity. An identity is where we have all real solutions. The 2 lines coincide. So when you go to graph this one, and then, let me just change my color here. Then you go to graph this one, they land on top of each other. That's what the graph would look like. If you go to solve it analytically, you would have 2x minus 6 equals 2x minus 6. Wait a second, that's the same thing. Or let's pretend you didn't even know that, and you go to just minus 2x. And you have -6 equals -6. Well, that's true. That means if it's a true statement and your x's disappear or your y's disappear, then you have all reals. Then your solution would be from -infinity to infinity. Okay? So, easy peasy. All right. Now we're going to solve some inequalities. I think I've got, just 5 more examples to show you. Okay, you can write this one down. What do you do with inequalities? Well, inequalities, you're solving it just like x, except you just have to add. Remember, there's multiple solutions that would make this true. anything less than this. So we solve it the same way. 3x minus 4x minus 8 is less than or equal to 2x plus 1. Let's simplify. This would be negative x minus 8 is less than or equal to 2x plus 1. Now, again, I would usually add the x over here, but I'm just going to subtract the 2x over to here just to show you. Negative 3x minus 8 is less than or equal to 1. Negative 3x, add 8 over 9. Now, here's something important. That's why I brought it over here. When you divide or multiply by a negative, you have to flip the inequality. And if you don't remember that, just write it down. When you divide or multiply by a negative, flip the inequality. So this would now be x is greater than or equal to negative 3. So how do we write that in a set notation? X is greater than negative 3. So if I can equal negative 3, that means I have a bracket. And greater than would go all the way to positive infinity, which is always open. There you go. All right, let's do another one. 2x minus 3 is less than x plus 2 divided by x negative 3. All right, let's see this one. So I have negative 3 that I'm dividing on this side. So I'm going to multiply this by negative 3 and this whole side by negative 3. And again, there's that negative. That gets rid of this denominator. And then I can distribute negative 6x plus 9. And then I have to flip this because I multiplied by a negative. And now we just go to solve. So I'll minus x over here, negative 7x. I'll minus 9 that way. Minus 7. And now I divide. Oh, so I flip again. X is less than positive 1. And again, let's write this as a interval. If I'm less than 1, that means I would go from negative 1 all the way to 1, not with a closed bracket because there's no equal sign. Okay, 4/10 x minus 4x plus 8/5. Definitely something that you want to try with these fractions. Again, I don't like fractions. I'm going to multiply everything by a common denominator. So you're multiplying each side by 10. Think of this being over 1. And I'm going to do it each piece separately. Times 10, times 10, times 10, times 10. The 10 and the 10 cancel, and you're left with 4 and an x. 1 is on the bottom, so there's nothing that cancels, but negative 4x times 10 is 40x, negative 40. 5 goes into 10 2 times. 2 times 8 is 16. And 5 goes into 10. 2 times 2 times 4 is 8. See, now I have no fractions. So now let's clean this up. This would be negative 36x plus 16 is less than or equal to 8. Negative 36x minus 16 over would be negative 8. And then there's that pesky divide by a negative again. So x is now greater than or equal to 8/36, which reduces to divide by 4 2/9. And to write that as a solution, we would have x is greater than or equal to 2/9. So 2/9 would be my lower bound, and greater than would go to the right. All right, and let's do a compound one. This is called a compound because they're together. What do you do when you have them all together? Well, you treat each side the same. You start in the middle, and you want to clear it of that negative 4. So you're going to multiply this side by negative 4 and this side by negative 4. So you would have a positive 8. This would be 5 plus 2x. And then this would be negative 80. Now, we multiplied everything by negative 4, which means we have to flip signs. So this would now be greater than, and this would be greater than or equal to. And then let's Again, we're working from the middle out, so let's take away the 5 on all sides. So that would be 3 greater than 2x greater than or equal to negative 85, and then divide by 2. So this looks a little strange because now you have your higher number and a lower number going from left to right. So you want to switch that around. So I'm just going to rewrite this backwards. So negative 85 over 2 is less than or equal to, again, I'm going backwards, x, which is less than 3/2. And we can then see that our solution, our x values would be between negative 85 over 2, and it equals that, could equal that, all the way up to 3 over 2, but it doesn't equal that, so parenthesis. All right, last but not least, intersection of graphs method for inequalities. Just want to show you how to do it on a calculator. There's the x-intercept way of doing it also. I'm just going to show you the one. Again, you're going to make this y1. You're going to make this side y2. And we're going to type 3x minus 2 times 2x plus 4. My son is watching something strange. And we're going to go to Zoom 6. Just see where they cross. It's good to have the colored calculators for this one too, because you can actually see. Okay, so they're intersecting right here. And again, you can hit second calc 5, enter, enter, enter. And it goes to negative 3, negative 5. We're not worried about the y, we're worried about the negative 3. So I want you to notice what this is asking. When is the y1 equation, which was my blue line, when is the y1 less than or equal to my y2 equation, which is my red line? Okay, so when is the blue less than the red? When is the blue lower than the red? And you can kind of see the blue line is below the red line on this side. If I were to draw an imaginary line right here, actually, let me draw it out right here. Okay, right at here at this negative 3 mark. And then let me change it to blue. See how the blue line is below the red line from here over, from negative 3 and greater, and then that would be our answer. So from negative 3, and it's bracket because it equals, there you can say the y1, this is your y1, is below y2, is less than or equal to y2. All right, practice some homework. Hopefully those are some good methods that helped you out.